Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico class, lesson number 12. In this lesson, we're going to be taking the RGB LED, connecting it up to the Pico and using the keyboard to send commands to adjust the colors. So let's take a quick look at the hardware and what I've got. A little hard to see on camera, but I do have the RGB LED that comes in the Kepler kit, which is a common cathode RGB LED, which means I'm going to wire the single long pin, the cathode, to ground. And then I've got three other anode pins, red, green, and blue. I'm running through a 220 ohm resistor for each anode, running it through a color coordinated jumper wire back to the Pico, and I'm using GPIO pins 10, 11, and 12 on the Pico. Now to make this appear better on camera, I'm going to use my trusty diffuser ping pong ball, which may or may not line up. There we go. And I'm also going to use my spotlight to put a little light on it because I found that that helps get the colors a little more accurate on screen. So let's go ahead and, if my mouse cooperates, run the program. That mouse is not cooperating, so let's do it this way. All right, which color would I like? So let's just start with red. And that works wonderfully. How about green? Well, that looks a little cyan on camera, but believe me, in person, that is a green LED right there. So let's go ahead and try blue. Oh, we can't do blue. It's not a special occasion. We must move on. Let's try for cyan. And again, that almost looks the same as the green on camera, but in person, that is a very different color. Let's try magenta. And a trickier one, yellow. We'll try yellow. That looks a lot more yellow in person. On camera, it looks a bit orange. But now we'll try orange. This should look deeper orange then because it is actually orange, if I can spell it correctly. And then we'll do a white. And you notice as I'm typing these that it's outputting the duty cycle values of the colors. And that's mainly for my own debugging and my own feedback, but it does have a useful purpose, so I left it in there. Now, we still have the problem because in the assignment we were told that we have to put blue out, but we can't do blue because it's not a special occasion. So is there a way that maybe I can tell my Linux computer to give me some blue? Maybe I can do a sudo and ask it somewhat politely but firmly if it'll give me blue. And there we go. Now it decided it's going to give me blue. And I can just type any command. I like typing off to turn the LED off. And now let's take a look at our code. I'm going to stop this here and we'll walk through our code. So I've got my three output pins, GPIO 10, 11, and 12. I've got a PWM object set up for all three of them. I've got the frequency set, the duty cycle of 0 to start with so that everything is zeroed out. And then I'm taking my input from the keyboard. Again, I'm in this while true loop. It's going to just ask over and over and over for my input of which color. And then each time through the loop, we're going to reset to 0. And then we walk through and now we start matching the actual colors. So in red, in the case of red, we're going to set the red value to 255. Green and blue are 0, 0. Green, we're going to do red 0, green 255, blue 0. Blue, we can't do blue, but we can do a sudo give me blue. And so that we're going to set the blue to 255 and the others to 0. Cyan is, of course, a mix of green and blue. Magenta is a mix of red and blue. Yellow gets a little interesting because theoretically it should be a mix of red and green. However, when I did this with a value of 255, that should have worked, but it ended up looking very green. So I wanted to back that down and give it a little truer yellow. And when I backed this down to 128, it gave me a very nice golden yellow. Orange becomes an even more interesting one because orange is halfway between red and yellow, but my red is already at 100%, so how am I going to go halfway? And basically what I have to do is I have to take the yellow values, cut them in half. So I go 128 and 64, and then I mix the red back in, so that means I go up, add 128. I end up at 255 and 64 for orange. Now white should be 255, 255, 255. However, I found that I can get a truer white. Again, there's just a little bit more green and blue than I was expecting in this mix, so I backed it off a little bit. And this gives me, at least in person, maybe not on camera, but in person, it gives me a truer white. So now you're looking at this wondering why I'm doing it in terms of 0 to 255 when my duty cycle is 0 to 65,535. And the reason is I'm thinking forward. I want to do some other things with this function, with these values, and I want to take more colors in the future. And 0 to 255 is kind of the standard range that we use for that. And so I want to do all of my color balancing in 0 to 255, and then we'll run through some math to write it out. So let's just do that. And again, we have to consider the fact that our output is linear, but the color is exponential. So we have to do the translation once again. So first we're going to do, again, a halfway point. Anytime I'm taking one set of numbers as input, one set of numbers as output, I like to convert it to a percentage in between because it just makes it easier to do the math to go from one set to a percentage, 0 to 100. That's pretty easy math. And then as the output takes 0 to 100, that way I don't have to try to mesh this color value with this color value. I can just convert it to a percent and just kind of do, it's two steps, but the math just comes out easier. So first I'm just going to take my raw percent, which is easy, 0 to 255. I'm just going to divide by 2.55, and then I have a value that's 0 to 100. Then I'm going to move my mouse, translate my percentage to the PWM output exponentially. So here's where we go back and we take my percentage divided by 100, raised 10 to that power, multiply by 10. That gives me my exponential percentage value, like we discussed in lesson 11. I will again have this corner case of if the value is 10, I really mean 0, and I have to do that for all three colors, not just the one LED. And then once I have that, then I can actually take my newly modified percentage and write it back out to the LED. And I'm just going to take my 65,535 divided by 100, multiply it by the percentage, and then I have to send that to an integer value because the duty cycle cannot be a float. It has to be an integer. I want to do this as all floats because that way, when I'm doing all that percentage calculation, I get several digits of precision. Whereas when I write it out, I want it to be an integer. So I'm going to write it out there as my duty cycle, and then I'm going to display it on the screen again, just mainly for my benefit to see what those values are. Now there's one thing that maybe you caught it, maybe you didn't. You'll notice that I have to be very careful about case sensitivity. And makes you wonder, is there a way around that? And I should have scrolled that up. You might have just seen it as I scrolled through. There is a way around that. So let's run this program, and I'm going to do uppercase red, and I'm going to do lowercase green, and I'm going to do mixed case yellow, and I'm going to do orange. Oh, what happened to orange? White. White's fine. I can even do uppercase white. This fun one. Sudo give me blue. But I can't have orange. Interesting. Let's take a look at the code and see why. So as I look through the code, it's exactly the same code until we get to one specific spot. And what we're doing here is I'm taking the input from the keyboard, and then I'm implementing a method. Now we haven't learned this in class. This goes beyond what we've learned in class, but as we're taking input from the keyboard, this is a really handy tool to use where we take the input string and we convert it to a lowercase string. So regardless of the case going in, it converts it to a lowercase, and then I'm going to compare it as a lowercase. So even if I send it uppercase red, it's going to convert it to lower and then compare it against lowercase red. Same with green, same with blue, same with sudo give me blue, cyan, magenta, yellow. Oh, look at that. I missed one. Orange is mixed case. And isn't it interesting because no matter what I type here, it's never going to match. The only way I can get that to match is if I do a comparison to a lowercase o, and let me try that again. And now, just like that, now I have my orange. So that's a little caveat. I made sure to leave that in just for you, so you can see that that is a caveat when you're doing these string comparisons and you decide to force it to lower. There's also an upper method that you can force it to. You have to make sure that you're comparing in that case, then otherwise it will fail and you won't get the results you're wanting. So anyway, I hope you enjoyed that. I certainly had fun with that, and I'm looking forward to more videos with the RGB LED. Lots of fun in store for us. Look forward to seeing you next time. For Simply Brian Enterprises, I'm Brian, and thank you for watching.